Sheet Metal Training Step 3.9, Rectangular Joints and Sealants. Once inside the data file, select the Rectangular Joints and Sealants button. Listed on the left-hand side is the 22 available codes. These 22 joint connectors are for all pressure files that you have in your current setup. We'll start with the top and use the TDF-TDC to describe the page. The bend allowance for TDF-TDC is 4 inches. In other words, we're taking 2 inches away from each end of the duct. Additional straight allowance is the next column. So if your joint connection requires additional straight before the joint allowance is taken away, you can add this in. We'll describe this column in more detail later. Horizontal, description, and costs. So if you have additional joint allowance you wish to use for the horizontal, you can put it in here. Cost is 29 cents per foot. Vertical and horizontal costs are always entered per foot. The 29 cents is going to be for the cost of a single cleat or clip. The vertical cost and description is the same. Each assembly is for the items that are going to be required to make up the joint connection, such as the 8 corners, 4 nuts, and bolts. $2.65 would be for that complete assembly. Looking at the slip and drive on line 2, we have a bend allowance of 1 inch. This is going to be the number of inches taken away from the overall raw to raw duct in order for this joint connection. 1 inch covering the half-inch drive turned on each end. The horizontal description is for the flat slip, and it's going to be 30 cents a foot. The vertical description is going to be for the drives, 20 cents a foot, and we have an additional allowance of 3 inches. This 3 inches is dictating that we're going to add on additional 3 inches to the length of the drive, per drive. So if you have 24 by 12 duct and it's slip and drive, the drives are not going to be cut at 12 inches, they're going to be cut at 15 inches for that additional amount that you need to bend over to the top and the bottom to keep the drives from sliding off. There is no each cost because there is no other components required to make a slip and drive connection. Standing slip and drive is set up the exact same way. Now code 4, ductmate 35, we can see that there is no bend allowance because it is a slip-on flange. Looking at the horizontal description, we can see that it is the cost of ductmate per foot times 2 plus the cost of a clip. So the ductmate is going to be slid on the beginning edge and the trailing edge of the ductwork, both top and bottom. The program will double the cost for the top and bottom, but if you have to put the flange on both the beginning of the duct and the end of the duct, you will need to double the number. So this $1.35 in a sense could be 50 cents a foot for ductmate and 35 cents for the cleat, adding up to $1.35. And obviously the vertical cost would be the exact same. And then the component cost, $4.20, would be for the 8 corners and 4 nuts and bolts to make up a ductmate connection. You can also see, just as the seams and sealants page, when it comes to welded, we did not include any additional cost here, as that's going to be covered in the joint sealant. However, since most typical welded rectangular ductwork has a half-inch flange turned out on both ends of the duct, we have put in a bend allowance of 1 inch. We've also got stainless steel setups and aluminum setups and a ductboard setup that will need to be looked at. Located at the bottom of the screen, you'll find the joint sealants page. This page will store the 22 available joint sealants for your rectangular joint connectors. You'll see that there's a description, a cost per foot, and a feet per hour for installation. Butyl gasket costs 10 cents a foot, and we can install it in 450 feet per hour. Duct sealer is set up with a 12-cent cost per foot and 285 feet per hour. MIG welding is set up with a 23-cent cost per foot for the consumables, and then 13 feet per hour for the welding. Please keep in mind that this will include tack welding, then continuous welding, then cleaning this weld with either a grinder or a wire wheel, and then possibly painting it to keeping it from rusting. Looking over to the right in the notes, you'll see that we put in our average coverages just as we did on the seam sealants page. Let's return to the joints and now select the per joint setup. This page will allow you to match the joints and the joint sealants that you wish to have allowed. For example, TDF-TDC, we wish to allow neoprene gasket and butyl gasket. Slip and drive, we're only going to allow duct sealer, silicone caulking, hard cast foil grip tape, and aluminum foil tape. In the middle here, you'll see labor tables. The TDF-TDC section, the labor for fabrication is going to be the amount of time it takes to run the item through the TDC machine. The attached labor will be the amount of labor required to insert the corners into the item prior to it leaving the shop. Both the fab labor and the attached labor are considered a shop labor. The field labor is going to be for making a field connection. Listed below that, you can see there's an option which says check to use connector fab labor on straight duct, meaning does your coil line turn the TDC flange for you? If this is true, you will uncheck this box, and on standard length pieces of straight duct, the program will not use the fabrication labor column. It will only use the attached labor and the field labor. If it's a flange joint connection, you will want to check this box so that it includes the proper number of footage for a duct-mate flange or a TDC flange on your reports. You can also see that we have columns for scrap, number of corners, cleats, screws, nuts, and bolts. This is merely for counting purposes. So if we go to duct-mate, we'll see that we have an 8% scrap factor, 8 corners, 1 cleat per foot, 2 screws per foot, and 4 nuts and bolts. Also listed down here at the bottom, you will see pounds per lineal foot of horizontal and vertical, and then pounds per each. So if you wish to have the weight of the joint connection included in the overall duct pounds, you must fill in these locations. The last section to look at is the maximum vertical size per joint. Within the pressure file, you can state that you want to use at a 24 by 12 duct size, that you would like it to use slip and drive. However, if the drive side or the vertical side gets too long, you can force it to change to another joint connector. So for instance, looking at this screen at the bottom, we will see that it says a 24 by 18 would still use slip and drive. Once we reach 19 inches, the program will force the joint connection over to a number 1, which is TDF-TDC, and also change the joint sealant code over to a number 2, which is butyl gasket. All of this change will happen without the user even seeing it. It will become the new default for this particular item. So if we go back to the rectangular joints, we've now concluded the walkthrough of the rectangular joints and sealants setup.